thank you so much for the intro, guys. Yeah, my name's Chris Hutchinson. I'm head of customer success here at TravelTime. And yeah, just to give you a very brief intro to what we do. We basically provide an API and a set of plugins into other third-party tools that let you essentially search the world by travel time instead of by distance. And this can be used in a kind of a whole range of different use cases. And yeah, Dan and Conchita and Senia will talk about some of them later. But these kind of break down into people who have search sites where they want their users to be able to search listings by travel time. So, job sites, recruitment sites, that kind of thing. And then also the other side is what we call analytics. So sort of using business data and intelligence to make better decisions using travel time. And I'm just going to give you, a little bit of a kind of introduction into how travel time data can be used in the sort of site selection process. So yeah, just quickly what I'm going to go through. Very sort of brief introduction into sort of what site selection involves and therefore kind of why we're talking about it. Then a sort of behind the scenes in terms of how we do what we do at travel time, from the data we use to how we build the models, how we make that accessible to people. And then just at the end, a very short kind of detour into something that is not traditional travel time analysis, but looking at how you can kind of use some of our data to do analysis of CO2 emissions and how that can be relevant for site selection. So I'm going to kind of look at site selection through the lens of catchment areas, because a catchment area is obviously a great way to kind of analyze the feasibility of a site, because you can lay over the top of that catchment area all sorts of other data sets and look at population catchments, proximity to customers or suppliers or competitors, and all of that kind of good data. And the simplest way to do this is just to take a distance catchment area. So sort of 1.0 would be, let's do here a 20-kilometer radius search around this potential site that we're looking at. And this could be sufficient for a lot of use cases, but a lot of the time it will actually, it will fall down because human beings can't move in a straight line. We're all kind of at the mercy of the transport networks. And so if you're trying to look at, can people actually access this site, then we need to start looking at the transport networks that are available to them. And so we evolve into catchment area analysis sort of 2.0, and this is to look at the road network. So this is a 1 hour driving search from that same location, and it now shows you actually what is the catchment area in terms of people who can drive for an hour or less and get to this site. However, this is still, it's a definite improvement on just a radius search, but it's still just giving us part of the picture. That part being driving access. And this is a site in central London. Not many people drive to, say, an office in central London. So we actually need to be able to look at a catchment area in terms of all possible types of transport, be it driving or walking, cycling, and crucially public transport. So this is where we get to kind of our focus at travel time, or one of our primary focuses is to enable this sort of catchment area and travel time analysis to be done for any range of transport. And here we're looking at a 1 hour public transport search. So showing you the areas that are reachable within 1 hour of this site by public transport. And as you can see, it's a very, very different shape to the driving area. We get these kind of islands and holes, islands being potentially where there's a train station that you can get off the train and walk, but you can't actually get to the area connecting those points. And why is it important to look at kind of all of these transport types? So this is kind of comparing the driving area and the public transport area. And what we can see is if we were just to do this catchment area analysis using driving, we kind of hit a couple of potential problems in our analysis. The first one being these red areas that are areas we'd be missing. So these are areas that are reachable within an hour by public transport. Potentially there are people who, demographics who live here who we want to include in the analysis we're doing, but we would be ignoring them if we just looked at a driving area. And sort of conversely, the blue areas are those that are reachable by car, but aren't reachable by public transport. And this can be important, if we're looking at doing a commute analysis for this site. So if we're including these blue areas, we're kind of making the assumption that people are happy or able to drive to this location. And if that's not a kind of valid assumption, then potentially including these blue areas in the site selection process might not be wholly appropriate. So that's kind of just setting the scene for why we do what we do, is to ensure that all available data for any kind of transport type is there for this site selection process. And I'm just going to walk through kind of what that looks like from our perspective. So we obviously start with data. So data is kind of the heart of everything we do. And it's a huge focus for a very, very kind of large chunk of the business. Data in terms of, we have 44 countries available for this analysis. Even just on the public transport side, this is over 3 million different public transport stops. And there's a huge number of public transport agency data that we kind of pull together and consolidate. So even in the UK alone, we have over 1,000 different public transport agencies whose data we are building into our models. And not only does it have to be kind of comprehensive, it needs to be up to date. So, we keep this data and refresh it at least every 2 weeks to make sure we're always giving the kind of latest view of the world. And also it needs to be transparent. So particularly from sort of, a real estate consultancy perspective, if you're advising a client on where to relocate an office to, they need to have kind of confidence that the right data is being used. It's all very well showing, here's a public transport catchment, but you need to know, what data is underlying that. And we publish all of that, completely transparent on that. We even have a sort of online tool that we've built to show exactly what data we have and where it is. And that's what that's showing on the left is just the UK, exactly where we have data. We then build some models over the top of this. And I promised not to kind of show any code in this presentation, so not to bore everyone, but just I thought I'd actually talk about some of the kind of core principles we use when we build these models for all the different transport types. The first one is we want them to reflect how people actually move around the world. So for example, in our driving models, it's not just driving. If you start a journey away from a road, in real life, you can't just magically start at the road. It takes you time to get to the road. So we apply a sort of snapping penalty based on how far away you are from the road to sort of simulate you walking to where you can then start your journey by car. We explore every route. So when we're doing one of these catchment areas, for example, the models will traverse every possible driving route or public transport route available. And we don't sort of cut corners when we do this. So for example, when you get to a public transport stop, we don't just draw a circle around that and say, this is where you could walk to from that stop. We actually run a full walking search from that public transport stop to show you exactly where you could get to on that journey. We also build kind of transport modes that reflect what people actually need and choose. So going back to public transport, it's fully multimodal. So people don't just travel by train or just by bus. They want to travel by train and bus and ferry in the same journey with walking, and that's what we support. And we also have things like a driving and train model. So this was built for the kind of typical commute where someone might drive to a local station and then continue their commute by train. Again, building models that actually reflect what people need. And we try and make them at the same time very simple, but also very configurable. So things like being able to change how much you allow someone to walk during a public transport route, which doesn't sound that important, but when you're comparing analysis in sort of rural areas where people might be willing to walk further to get to a bus stop or a train station, it can be really important to be able to play around with these parameters. And also, I think in the context of COVID, being able to really configure these kind of things is super important, because everyone is kind of changing how they behave and commute and work, and therefore kind of just relying on sort of standard old simple travel models is not always that appropriate. So we then make these models available, and we do this all through an API. We are kind of obsessed with performance. So as I mentioned, one of the use cases we have for the API is to be on search sites. So allowing consumers or customers to search listings by travel time. And the key to that is performance. So anything that slows down a site is going to churn the traffic. So we have to be able to calculate hundreds of thousands of travel times incredibly fast. At the sort of peak of what we can do, we can now do 100,000 travel times in about 145 milliseconds. And going back to sort of the analytics side, even though performance is not sort of the be all and end all, because the same API we have underpins all of this, the benefit in analytics is being able to do kind of huge data analysis at scale, scenario model, just rerun things in a sort of very, very manageable time frame. And also, because it's all through an API, there's no sort of hosting, there's no like GTFS configuration or having to build your own models or anything like that. It's all kind of always available through a simple API, kind of however you need to use it. And this also lets the technology scale for whatever use case. So the same tool or the same features can be used, for example, to do a 1 minute walking area on the left there. So we have clients who use this for kind of last minute delivery or curbside pickups, where you need to know the really granular detail, versus on the right hand side, a sort of 8-hour driving area for kind of logistics planners who are trying to work out huge driving areas. And it's exactly the same technology and access that underpins both of these kind of very different use cases. And then what does this API actually look like in terms of features that you can use? So we have sort of 3 key features of the API, and these are available, as I'll talk about in a sec, through kind of plugins we have into third-party tools as well. So we have the ability to do isochrones. So as Alex showed at the beginning, that idea of kind of how far could you get from London in 10 days, 20 days, 30 days, exactly that. How far can you get in 30 minutes, public transport or driving or whatever transport mode you want. We have the ability to do matrices, so lots of origins, lots of destinations, very quickly calculate the travel times between all of them. And also a sort of an offshoot of that is search. So when you have essentially one origin and lots of destinations, the ability to search those destinations by travel time, for example, on a consumer-facing site. And then we have routing. So this is sort of A to B, turn-by-turn directions between origins and destinations, again, for any transport type that you need that for. And this all kind of comes back to data. So as we'll see from the talks that follow, site selection kind of means many different things to different people. But our part in that is actually quite a simple one. So we don't try and build end-to-end solutions. We don't build our own GIS tools. We're not trying to build our own kind of search engines. What we do want to do is to make sure that our data and our services and processes are available wherever a client might want to use them. So if that's through a direct API integration, it might be on a property site like Zoopla, or we're now powering NHS test and trace in the UK. So if you try and search for a coronavirus test, it will allocate you to your kind of most convenient testing center based on travel time rather than straight line distance. Or it might be through one of the plugins. So we have integrations into Alteryx, into ArcGIS, into QGIS, to enable people to kind of plug and play using the API without having to write any code. There are plenty more we have on our roadmap, so things like Tableau, Salesforce, yeah, actually, I wanted to ask if people have tools that they use where they think, you know, TravelTime would be a beneficial kind of addition to that tool. Please just, yeah, either reach out to us afterwards or even pop them in the chat. Because yeah, we're always keen to kind of learn about where our data would be useful. And yeah, I said I'd just touch on a short detour around CO2 emissions. So yeah, the clue is in the name, travel time. We focus on travel times, and we think it's a pretty important data point when doing site selection. But as sort of something that's come up more and more when we talk to clients is actually people wanting to do a sort of analyze emissions, and particularly CO2 emissions, when considering, for example, where to locate an office. And yeah, it gives you another data set to use in the evaluation process. And it means that if you can kind of reduce those emissions, you can potentially kind of meet regulatory requirements or help with your CSR initiatives, or even kind of potentially help retain employees who are particularly sort of environmentally aware and focused. And our data can be used in a couple of ways. First of all, because we support all of the different transport modes, being able to do the analysis of public transport and cycling and walking means, you know, you can select sites that are more accessible for those kind of greener transport modes, rather than just relying on which is the best for driving. And also for driving and public transport, we not only return travel times, but we also return distances. And distances is normally the sort of key piece of data that you use to calculate CO2 emissions. So what you can do is you can take the distances from travel time, you can use some kind of conversion factors around emissions per kilometre for cars or different types of public transport, and you can actually then build a sort of origin destination matrix of emissions as well as travel times, and yeah, it just gives you another piece of data to use in that site selection analysis. Cool. Yeah, that's it from me. Thank you. Yeah, thank you very much for having us here and for listening. Yeah, please do reach out if you have any questions or you want to discuss how you think we might be able to help you or work together in the future.